right, problem 18. There we go. It says find the value of the variables in each figure. So on part A, first thing that I notice is that there's an x right here as part of this angle and an x here as part of this angle. These two angles are corresponding angles. And what do we know about corresponding angles? They're the same size. They're congruent. So we're going to take these two expressions and set them equal. So I have 10x equals 2x plus 80. Subtract 2x from both sides. So 8x equals 80. Divide both sides by 8 and we get that x is 10. There is another variable in the picture. There's a y right here. What's the relationship between these two angles? What do we call that pair of angles? A linear pair. And what's the relationship for a linear pair? Equals 180 there, supplementary. So I can take y plus 3 plus 2x plus 80 and set it equal to 180. And we just found out that x is 10, so I have y plus 3 plus 2 times 10 plus 80 equals 180. So y plus 3 plus 20 plus 80 equals 180. So y plus 103 equals 180. Subtract 103 from both sides. And I get that y equals 77. Where should we start on part B? X. There's an x here and an x here. So I want to look at these two angles. What's the name for that pair of angles? Yes, alternate exterior angles. And what's the relationship on alternate exterior angles? They are congruent. So we're going to take those two expressions and set them equal. 7x minus 4 is equal to 6x plus 2. Get my x's to the same side, so we're going to subtract 6x from both sides. That gives me x minus 4 equals 2. Add 4 to both sides. And I get that x is 6. All right. Now I want to look at these two angles. What do we call that pair of angles? vertical angles. And what's the relationship for vertical angles? They are congruent. So I'm going to take those two expressions and set them equal. 7x minus 4 is equal to 2y plus 6. And we solved for x already. We got that x was 6. So I have 7 times 6 minus 4 equals 2y plus 6. What is 7 times 6? 42. 42 minus 4 equals 2y plus 6. 42 minus 4? 38 equals 2y plus 6. Subtract 6 from both sides. I get that 32 is equal to 2y. Divide both sides by 2. And y is how big? 16. Beautiful work. What else would you guys like to see off of the review? Yes. Number 1, and I heard another one. 23. Let's do 1 and then 23. All right, so for number 1, there are a whole bunch of right answers for any of these. One of the things that I'm going to be looking for on a question like this is the notation. Part A, I need a ray that contains point E. So I could do ray EF. I could do ray EJ. I could do ray FE. I could do ray JE. And this last one, I could also do ray FJ. Ray FJ would have its endpoint right here at F. And then a ray goes forever in one direction. So if it's heading this way, it is eventually going to intersect with point E. So all of those work as rays that contain the point E. One of your safest bets on a problem like that is to name a ray where you're actually using the letter, the letter for the point that they're asking you to use there. As long as your ray name has that letter in it, it's going to contain that point. A line containing point F. So we could do EF. This notation is different. This one has arrows on both ends. A ray just has arrows on one end. We could say line JF. I could even say line EJ. Because again, it continues on forever. If I name this, but it has the arrows on it, it continues on forever. It is going to contain point F. When we name lines, it does not matter if the letters are switched around. It's considered the exact same name. With rays, that's not true. With rays, the order of the letters does matter because it only continues on forever in one direction. Whichever direction it's continuing on in is the second letter in that ray name. Part C, a line segment containing the point G. We could have segment HG. It needs to have segment notation over the top. That's a dash with no arrows. Or we could have segment JG. Again, the order of the letters doesn't matter, so HG and GH are considered the exact same line segment. 3, collinear points. What does it mean to be collinear? All on the same line together. So points E, J, and F are all on the same line together. Or you could answer what? And it would still be 3 points that are all on the same line. H, J, and G. Something I want to point out about the figure, I meant to mention this at the beginning. There is no dot right here at J, but it is where the 2 lines are crossing. That is a point, even if they don't put the dot there. So just because there's no circle there, no little filled in circle, does not mean that J is not a point. Part E, an angle containing the point H. Again, I'm looking for notation on these. If you just write down 3 letters, even if it contains H, it is incorrect because you did not name an angle. So you could say angle HJE. Angle HJE would be this angle right here. Or you could have angle what? HJF. I heard HJG, that would be considered a straight angle. But I would encourage you to stay away from straight angles because it tends to cause confusion later. But I would count HJG as an angle that contains point H. 3 non-collinear points. What am I looking for now? Not on the same line. Two points will be on the same line together, but the third one should not be lined up with the other 2. So I could do HJE. These 3 points right here. I cannot draw one single line through and hit all 3 of those points. We can do HEG. I could do FJH. We could keep going on and on and on with this. So there are many, many, many more that are 3 points that are not all on the same line together. Pair of vertical angles. You have to have your angle notation here. Again, if you just write down 3 letters, it is not considered to be correct. If I did angle EJG, this angle right up here, what would be the vertical angle pair for EJG? HJF. What about if we'd gone the other way? What about if I said EJH? GJF. All right, angles that form a linear pair. I'm going to start with EJG again. So if this is the angle that I start with, what would form a linear pair with EJG? FJG. Or which other one would also work? What other angle would form a linear pair with EJG? HJE, yes. So there's 2 sets of linear pairs. What about for this angle, HJF? What would be a linear pair with angle HJF? HJE. What's the other one that would form a linear pair with HJF? GJF. Make sure you are using your angle notation, your segment notation, line notation, ray notation. You have to have the correct notation, not just the correct letters, because you are showing me that indicated object. Yes. What else would you guys like to see off the review? 15. Oh, sorry, and I forgot 23. We're going to do 23 and then 15. I'm so sorry. 23, then 15. 23. Which figure in the diagram is a rotation of figure 2? Well, here's figure 2. And a rotation of figure 2 could look like this, or this, or this. Are there any of them that look like any of those that I just did? 5. Any others? 4. So figures 4 and 5 would be rotations of figure 2. Which figure in the diagram is a translation of figure 3? So figure 3, get this off of here. Which one is a translation? Figure 1. Or translation is a slide. Up and down or left and right. Yes. We can move up, down, we can move left, right, so it can appear to have moved diagonally, but it needs to have the same orientation. So like on this orange, the stem is up and the leaf is on the right. If it's a translation, the stem is going to be pointing up and the leaf will be on the right. If it has the stem and the leaf in any other spot, it would not be a translation of figure 3. What about a reflection of figure 5? Figure 1. A reflection should look like a mirror image, so it should look basically completely backwards. In figure 5, the leaf is on the left. In figure 1, the leaf is on the right. Figure 4 has the same orientation as figure 5, so that would not be a reflection. All right, 15. On number 15, we want to know the algebraic property of equality, the definition, the postulate, or the theorem that could be used to justify the statement. So on part A, I have this lovely figure right here. And it says that Ki, this length, plus Ia, this length, when I add those together, it gives me the length of the whole thing, Ka. What allows me to take the lengths of 2 smaller segments, put them together, and get the length of the larger segment? What did you say? Segment addition postulate. Part B, it says that the measurement of angle 1 is equal to the measurement of angle 3. So these 2 angles, it's telling me, are the same size. And then the measurement of angle 2 is the same size as the measurement of angle 4. What would allow me to make that statement? Vertical angles theorem, yes. Part C, angles P and Q are supplementary. Then that means when I add them together, they equal 180. What are we using there? Close. We don't have a supplementary angles theorem. I'll give you a hint. My 7-year-old doesn't know what the word supplementary means. What do you have to know before you could actually use the first part of this sentence to write the second part? The definition. You have to know what the word supplementary means. Supplementary means that their measures are going to add up to 180. So this is the definition of supplementary angles. Part D, if the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, and angle 3 is equal to angle 4, what would allow me to take angle 3 out and to put angle 4 in its place? Substitution property. Let's look down at E. Part E says the measure of angle SIK, this angle right here, plus the measure of angle KIT, this angle right here. If I add those two measurements together, it would give me the measurement of the large angle, angle SIT. What would allow me to make that statement? Angle addition postulate. Yes, you're absolutely right. If AT equals PC, then AT plus 87 equals PC plus 87. What would allow me to do that? How is this different from this? Yes. How is the end of the sentence different from the beginning of the sentence? What does the equation at the end of the sentence have that the equation at the beginning of the sentence doesn't have? Has an 87. Are we doing it to both sides? Yes. This is the addition property of equality. All those things that you learned in Algebra 1 about if you do it to one side, you got to do it to the other, those are properties of equality. So if you add something to one side, you have to add it to the other. That's the addition property of equality. If you subtract something from one side, you have to subtract it from the other. That would be our subtraction property of equality. Multiply by something on one side, so you have to multiply by the same thing on the other side. Multiplication property of equality. And then we have the division property of equality. If you divide one side by something, you have to divide the other side by the same thing. All right, you guys should know this one. We've gotten really good at this because of our proofs. What allows me to say that HI is equal to itself? reflexive property. Last one, part H. It says that angle 1, right here, is supplementary to angle 2. It also says that it's supplementary, or sorry, that angle 3 is supplementary to angle 4. What would we call that pair of angles right there that I have highlighted? A linear pair. So this is our linear pair theorem. What else would you guys like to see? (16, 17) and which one? 16? All right, 16 and 17 sounds good. Wait, didn't we already do 17? No, sorry, we did 18. All right, 16, they tell me that E is the midpoint of BD. So my first reason is because it's given. If E is the midpoint of BD, what does that mean about BE and ED? They're the same, they are congruent. So BE is congruent to ED. That is the midpoint theorem. If I have an equal sign in between them, then it's the definition of midpoint. If it's congruence in between them, then it's midpoint theorem. If BE is congruent to ED, what does that mean about their measurements? They're the same. So BE is equal to ED. That is the definition of congruence. If I have two things that are congruent, their measurements are equal. Where did this 5x minus 8 and x plus 20 come from? Came from the segments in the picture. Here's 5x plus 8 and x plus 20. So why did they replace BE with 5x minus 8? Why did they replace ED with x plus 20? What'd you say, Caitlin? Oh, I thought I heard you say something. What are we using to be able to do that replacement? Substitution. All right. When we are looking at an equation, like we have in number 4, first thing I want to ask myself is, are all of the variables on the same side? No. I need to get the variables to the same side. What operation would I need to use to do that? Subtraction. So we're going to use the subtraction property of equality. What would I have if I subtracted x from both sides? I would have 4x, and then what else? Minus 8 equals 20. If it's helpful for you, you can absolutely write down the operation in here, but that would not be considered part of the proof. You're going to show me after you've done the operation. That's what I want on the statement line. What you did goes over on the reasons line. All right, what would I do after this? Subtract 8, add 8 to both sides. So what property are we using? Addition property of equality. What would my equation look like after I add 8 to both sides? 4x equals 28. What would I want to do after that to get x all by itself? Divide. So we are using what property? Division property of equality. And if I divide both sides by 4, I get that x equals what? X equals 7. Nicely done. All right, let's look at number 17. Name a pair of corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, and consecutive exterior angles. We practiced doing this just a couple days ago on our warm-ups. I want to say it's probably been a week ago now, but we were practicing identifying our angle pairs again. Corresponding angles, these are ones that are in matching corners. There are 4 pairs. You only have to give one of them to satisfy this. Angle number 1, right up here in the upper left corner of where those 2 lines are crossing, would be a corresponding angle to which one down below? Angle 5. Angle 1 and angle 5 are corresponding angles. Can somebody give me another pair of corresponding angles? 2 and 6. What about another pair? 3 and 7. Is there another pair? 4 and 8. All right, now the really important part. We want to describe their relationship. So I'm looking for congruent or supplementary. Are corresponding angles congruent or supplementary? Congruent. Alternate interior angles. If I'm looking for interior angles, I can't be looking at any of these ones on the outside. What? Why are they congruent? That is a postulate that we were given. We were told when the lines are parallel, corresponding angles are going to be the same size. What would be a pair of alternate interior angles? Which ones? Not 3 and 5. 3 and 4, no. 3 and 6. Angle 3 and angle 6. Alternate interior angles need to touch the 2 different parallel lines, and they need to be on opposite sides of the transversal. What would be another pair of alternate interior angles? 4 and 5. What is the relationship between alternate interior angles? They are congruent. Part C, I want alternate exterior angles. So now I'm not looking inside the lines at all. What would be a pair of alternate exterior angles? Alternate exterior angles. 1 and 8. Or you could have named what? 2 and 7. What is the relationship between alternate exterior angles? What is the relationship between alternate exterior angles? They are congruent. Consecutive interior angles. When you see consecutive, that means same side of the transversal. I want interior angles. So again, I'm not looking outside the lines at all. What would be a pair of consecutive interior angles? 3 and 5. Or what? 4 and 6. What's the relationship between consecutive interior angles? Supplementary. All right, last one. Or not last one, but last one where we name angles. We want consecutive, so same side. Exterior angles, so I'm not looking in between. What would be a pair of consecutive exterior angles? 1 and 7. Or 2 and 8. What is our relationship with alternate exterior angles? Supplementary, absolutely correct. If you see alternate, they're going to be congruent. If you see consecutive or same side, they're going to be supplementary. And then we have our corresponding angles, which are also congruent. But alternate angles, whether they're interior or exterior, will be congruent. Consecutive angles, whether they are interior or exterior, will be supplementary. All right, and then there is a part F. It says, suppose the measure of angle 1 is 2x plus 20. So angle 1 right up here, 2x plus 20. And the measure of angle 8 is x plus 60. What do we call that pair of angles again? Alternate exterior angles. What's the relationship between alternate exterior angles? They are congruent. And what can we do with things that are congruent? Set them equal. That's absolutely right. So angle 1 is congruent to angle 8. That means the measurement of angle 1 is equal to the measurement of angle 8. So that means 2x plus 20 is equal to x plus 60. I'm going to subtract x from both sides so that I get my x's on the same side together. That gives me x plus 20 equals 60. And then I'm going to subtract 20 from both sides. And I get that x is 40. And then they want me to find the measurement of angle 6. Well, here's angle 6. What do we call this angle pair right here? What's the angle pair for 6 and 8. What would we call those? They're a linear pair. What's the relationship between linear pair angles? Supplementary. So they're going to add to 180. So the measurement of angle 8 plus the measurement of angle 6 equals 180 degrees. So I get that x plus 60 plus the measurement of angle 6 equals 180. And we just found out that x is 40. So I would have 40 plus 60 plus the measurement of angle 6 equals 180. What's 40 plus 60? 100 plus the measurement of angle 6 is 180. And then I have to subtract 100 from both sides, which means angle 6 is how big? 80. What else would you guys like to see? Number 19, absolutely. Write an equation in slope-intercept form. Slope-intercept form is y equals mx plus b for the line that passes through negative 2410. So here's my x and my y that it has to go through. And is perpendicular to this line. So I need my perpendicular slope. How do we find perpendicular slope? What am I going to do to the slope of the line that I have underlined to find the perpendicular slope? We're going to flip the sign. So it's opposite sign. And one other thing. You flip the fraction, opposite sign and reciprocal. Flip the sign, flip the fraction. So my perpendicular slope would be what? Negative 5 over 4. All right, we are going to use point slope form to do this. If you want this on the final exam, it needs to be on your cheat sheet. Point slope form is y minus y1 equals m parentheses x minus x1. Again, I'm not giving you any formulas at all on the final exam. So if you want any of the forms or formulas, you need to make sure that they are on your cheat sheet. Okay, so to get it in slope-intercept form, the y and the x are just going to stay y and x. Those other three pieces, y1, m, and x1, are all going to be replaced with numbers. So y minus, what was the y part of the ordered pair that they gave us? 10. So y minus 10 equals, we wanted this to be perpendicular, so we're going to use our perpendicular slope, which is what? Negative 5/4 parentheses x minus, what was the x part of the ordered pair they gave us? Parentheses negative 24. I already have subtraction there, So I need to make sure to put the negative 24 inside parentheses. What happens when I subtract a negative? Turns into a positive, so that's going to turn into a plus. Y minus 10 equals negative 5/4 times x plus 24. We're going to distribute the slope, distribute that fraction. Left side of my equation stays the same, y minus 10. Negative 5/4 times x is just negative 5/4 x. And now I need some help. What is negative 5/4 times 24? Negative 5/4 times 24.
Negative 30.
Negative 30 minus 30. The last thing I need to do to get it into y equals mx plus b form, I need to get the y all alone. So I need to add 10 to both sides. And so my final answer in slope-intercept form would be y equals negative 5/4 x minus 20. Got about 7 minutes until the bell for D-lunch. What would you guys like to see? I probably have time for one more. Yes. 36? Absolutely. Number 36. Complete the 2-column proof. We have 2 lines that they tell me we're going to use for our given information. So I'm going to put one piece of given information on each line. We're going to have AC bisects angle BCD on one line. And then we have BC is congruent to DC. I'm going to mark that on the picture. BC is congruent to DC. What does it mean that AC is bisecting this angle here? It's cutting it exactly in half. So what would that mean about angles 1 and 2? They are congruent. So angle BCA is congruent to angle DCA. What are we using to be able to say that? How did you know that that meant it was going to be cut in half? Because it says bisects. My daughter doesn't know what bisect means. So what are you using to be able to say they're the same size? The definition. Definition of what was getting cut in half? An angle. Yes, definition of angle bisector. Is there anything that I'm allowed to mark on the picture as being congruent even though they didn't give it to me? AC. AC is congruent to itself. What allows me to make that statement? Reflexive property. All right, let's look at these 2 triangles. Triangle ABC and triangle ADC. They are congruent to each other using which postulate? SAS, side angle side, yes. Triangle ABC is congruent to triangle ADC by side angle side. Here's a side, and then an angle, and then a side. The angle is between those two sides, and then in my other triangle I have side, angle, side that are marked as congruent. All right, really quickly, before I set you guys completely loose, the answer key for this final exam review packet is already posted in Canvas. I got that put up today. You have to go to today's module. In today's module, you'll see a page that says Review for Final Exam Day 2. You have to click on that page, and then you have to scroll all the way to the very last bottom. Down here at the bottom in large print, Final Review Fall 2023 Answer Key. That is a PDF that you can look at. I did go ahead and record our review session today, so I will be posting that on Canvas. So any of the problems that we went through together, you'll have videos for that. Monday, I will be doing videos in all of my geometry classes. So any questions that I don't get to in here, 5th period on Monday, you might want to check out the videos from the other classes to see if maybe I went over that particular question in another class.